Hey guys, since some of you guys have some problems doing this force deformation diagrams for this question, and I think it is quite important for you all to know how to draw it like exactly. So I decided to film this video so you guys can save it as reference for this step-by-step guide. So I'm not going too much of detail, but I'm just telling you what is essential to draw this force deformation diagram. So the first thing you need is this one over here, CS, CT, and we either need the FV or the FVM, depends on the question, or uh, the FB and the FKL. Okay, so I will be showing two examples later on. So right now, this case is giving an FB to us. And for this case, this is a tensile case. And if this is not existing and this thing over here is rotating and the force is transmitted by rotation, and it will be a shear case because the axis is not parallel to the screw axis anymore. So come back to this case where we have a tensile case. So the first thing is you have to calculate what is the FB in order to get the FKL as requested from the question. All right, so we have a total F pulling at 60 kilonewtons, and we have 6 screws. In this case, it will be FB. So our FB instead 60 kilonewtons divided by 6 and 10 kilonewtons. That means each of the screw has to handle 10 kilonewtons by themselves. Okay, so that is the required information that we have, and we can find FKL later on. This is required. All right, so first things first, plot according to what is given over here. So 25 kilonewtons at every 100. So this is the line for CS. Okay, I will use rate. Oops, use solid. So like that. And we have 20 kilonewtons at 20 micrometers, 20 and 20. So I will use green. And this green line over here has to be moved in such way that they are intersecting at F3 equals to 18 kilonewtons. So we have to find where is 18. So this is like 18. And somewhere around here will be it. So as you can see, this over here is 18 kilonewtons. And it is our FB. And yeah, that's all for the first not yet, because we are finding for FKL. And next thing is we have to draw one line over here, and this is the FB line. Okay, I'll make it a little bit shorter, too long. So this FB line has a 10 kilonewtons value, and this 10 kilonewtons has to fit in between this red and green line. So what you guys can do at home or in the exam is you have to use a ruler and see, oh, so it's like 43.2 millimeters. So you have to use a ruler and slowly measure, oh, so this is like 10, oh no, so how much is this? Oh, this is like too much, 50 point something. Yeah, so it's like too much. So you guys have to kind of like adjust using your ruler. But for me, I will just copy and paste. Yeah, the same length. So I will just adjust accordingly. And this might be over here. And whatever line down there, it's my FKL. So I'm using this dotted line over here. So this is my FKL. So it's around 10 kilonewtons as well. I might say it's like 10.5. So it's not allowing me to do it, but I would say FKL. So this is my FKL over here. The clamping force. So I would say it's around 10.5 kilonewtons. All right, so it's about 10. Okay, so the first question is done. The next thing is around the FZ. So this FZ means that it's a setting effect, and we have a nice graph over here, and we are looking at tensile case, and our surface roughness is at 30, as we can see over here, 30. So we will be looking at this column over here. All right, and thread area, we have one thread area, which is this one over here, okay, to screw in the nut over here. So we have one head and nut each, so one head, one nut. So we have two over here, and here comes the tricky part. So whatever is touching the head and nut is not counted. All right, so whatever marked in red over here is not counted. All right, these are not counted. Okay, and the yellow ones will be counted. So here and here, these are the separating planes. All right, so if I have another washer, for example, if I have another washer over here, okay, so this part, this over here will not be counted as well, but this one over here will be counted. All right, so yeah, this is the trick for it. And we have two over here, let's say, and we say fz equals to 1 times 3 plus 2 times 3 plus 2 times 2, and we plus another 15 as requested in the question, and we have 28 micrometers. And this 28 means that I have to move my graph to the right for 28. So I'm around 90 right here, so I move by 28, so I'm around 118 micrometers. So this is my 28, and I just have to move the graph to the right, make it longer and make sure it's parallel, and whatever is intersecting, okay, whatever is intersecting will be my FVM. So as you can see, FVM is bigger and FVM is a bit lower. So it is always the case that FVM is bigger than FV. So FVM means that the amount of preload that we are required to preload the system, so that we will see an actual FV, because some of the forces are lost to the setting effect due to friction and stuff. All right. So I'm not going too much into the detail, and yeah, so we are done with it. We found our FVM, which is requested, and we are done with our force deformation diagram. So we can look into another one, which is this one. But I will go through very quickly. So in this case, we are given FB and FKL. As I said just now, if we are provided FB and FKL, we can use to find FVM or FV. So in this case, they are requesting us to find FVM, which is the amount of force that we are clamping the two systems together. We are clamping in FVM, but in real life, we are looking at FV, which is a little bit smaller than FVM, as I said just now. So we have 59 and we have 24. Okay, so I'll draw it quickly. The rate is for the screw, so 59, I'll use a solid. 59 at 100, around here. Okay, and the green line for the clamp parts, 24, 24 at 20, right, somewhere here. And I have to draw my FKL. I will use black dotted. So 8 is around here, so this is my FKL. And my FB is 36. So 36 is around here. So after I draw all these things, so if you remember, the FB is somewhere around the right side and it must touch the green, like it is in between the red and the green of the right side of the red and the green lines. And the end of the FB is touching the FKL over here. So what we can do over here to find our FVM is I need to, as I said just now, you guys can use a ruler and measure what is the length and fit it into here. And this green line over here will be touching over here. And you can extend it and make sure it's parallel. And this line over here will be my FVM. Okay, so we are doing right now in reverse process, FVM. Okay, so I hope you guys get what I mean. I'm going through very quickly and briefly. So I'm just doing in reverse. Just now I drew just now for that case we drew that line and drew that line because we know exactly how much is my FVM or the FV. And right now we are given the FKL and the FB, and we are drawing what is the FVM based on the information that we know from the FB and FKL. All right, so we can skip this part because you can use the formula such that elongation is equals to the FVM over the CS, or the ET is the same thing, CT, and all you can read from here. So this line over here, okay, is telling the ES, and this line to this line over here is telling the ET. All right, nothing too special. And go to FZ. Okay, so go through it very briefly. So one thread area, one head, one nut, and whatever the head and nut is touching will not be counted as separating plane. Not separating plane, not separating plane. This is a separating plane. So I have a 3 for thread area, 2 times 3 for the head and nut, and 1 times 2 for the separating plane, and I will have 11 micrometers. All right, so 11 micrometers means that I have to move from here, which is around 60, 70, 82, and I have to move 11 micrometers to the left because FV is always smaller. All right, so 11 is 71. 71 is around here. So I'll copy this line again. So I'll move it 71, and this cross section over here will be my FV. That simple. All right. So FVM is found, which is around 33 kilonewtons, and FV is also found, which is around 28.5, I say, kilonewtons. All right. So I hope this can help you guys in solving the different types of question in the exams. And that's all from me. See you guys. Bye.